Hey guys, so the last topic we want to discuss in this chapter is something we call hybridization. Okay, so it's a bit of a higher level topic, and if you pursue chemistry at a higher level, especially organic chemistry, you will spend a great deal of time discussing hybridization. We're just going to spend a very brief amount of time on it this year, just discussing the absolute basics of it. That way, when you hear about it in college, it won't be completely new to you. Okay, so if you think back to chapter 3, we recall that an orbital is just a space where we likely find an electron. Okay, so it's an area within the electron cloud where a specific electron is likely to be. Okay, so we might have orbitals in the s sublevel or in the p sublevel or so on. Okay, so hybridization is simply when these orbitals mix together to produce a new type of orbital. Okay, so you might have some s's and some p's mixing together. You might have one s and one p. You might have one s and three p's mixing together. Okay, but anyway, whatever happens, your result is a new type of orbital. Okay, so if we think about what we know about these types of orbitals, an s orbital, we remember, is spherical in shape. Okay, so if we wanted to represent it, we would probably just draw it as a circle. Okay, so best we can draw a sphere. Okay, so you have an s sublevel that's spherical. It is typically lower in energy than the corresponding p orbital. So remember, every orbital can hold 2 electrons. Okay, so an s orbital could hold 2 electrons. A p orbital, okay, typically there are 3 orbitals in the p sublevel. They are dumbbell shaped. Okay, so if I wanted to draw that, okay, we would see that. And I'm not a great artist, I apologize. They have the shape of a dumbbell. Okay, so when orbitals mix together, let's say I had a p and an s orbital mixing together, or hybridizing is the phrase we would use there. It adopts some of the characteristics of both the s and the p orbital. Okay, that includes its energy and its shape. Okay, so I'm not even going to attempt to draw it. I won't require you to draw it. It's kind of an abstract thing to think about. It would have a shape somewhere between that of the s spherical orbital and the p dumbbell shaped orbital. Okay, so the main thing to be aware of is that the hybrid orbital has characteristics that are some combination of what you observed with the s and the p orbitals. Okay, so also it's typed out here that energy associated with sp, sp2, and sp3 hybridized orbitals have more energy than s but less than that of p. So the hybrid orbitals fall in energy somewhere between the 2 parent orbitals. Okay, so you can look at these names of these hybrid orbitals and probably guess what produced them. Okay, so an sp hybrid orbital is produced when one s and one p hybridize or mix. sp2 is produced when one s and two p's hybridize, and sp3 would be produced when one s and three p's hybridize. Okay, so that's all you really need to know about that. A couple of other terms I want you to be familiar with, but we won't spend much time discussing, are the phrases sigma and pi bonds. Okay, so sigma bonds typically occur between s orbitals or hybridized orbitals. Okay, if we're thinking about just carbon and hydrogen here, carbon is the common example we use to discuss hybridized orbitals. So sigma bonds are typically the first bond that form between, let's just stick with the carbon example. So the first bond that forms between 2 carbon atoms. Okay, so if I have a carbon bond, I would have a single sigma bond. Okay, so if you want to associate single and sigma, that's perfectly okay. So then a pi bond, okay, they are the additional bonds that might form between carbon atoms. Okay, and they are the bonds that occur between 2 p orbitals. Okay, so if I have a carbon double bond, okay, the first bond would be a sigma bond. The second bond would be a pi bond. Okay, so I have one sigma bond and one pi bond present there. So if I have a carbon-carbon single bond, a carbon-carbon double bond, and a carbon-carbon triple bond, okay, the carbon-carbon single bond would be a single sigma bond. The carbon-carbon double bond would be one sigma bond and one pi bond. The carbon-carbon triple bond would be 1 sigma bond and 2 pi bonds. Okay? So going anywhere beyond that will get pretty complicated pretty quickly, and I'm guessing you're probably a bit confused already. That was a 5-minute crash course on a topic that would take hours to teach. So mainly what I want you to know for the sake of this course is simply the definition of hybridization, what it is, okay? Then just be aware of what sigma bonds and pi bonds are, okay? So if I gave you a carbon-carbon single bond, just know that bond would be labeled as a sigma bond. If I give you a carbon-carbon double bond, know one of the bonds is a sigma bond, one is a pi bond, okay? So hopefully this video wasn't too terribly confusing, and you can just remember those two basic things and you'll be good moving forward. Then when you get to college level organic chemistry, at least the phrases won't be completely new to you.